So today we're going to be learning about compound inequalities, thinking about the word compound. If we have a compound word like butterfly, we have two words. Well, compound inequalities, we have a compound word, but like an inequality, so two inequalities. So for example, I have -1 is less than x, which is also less than or equal to 3. We can write this out as two separate things. We have -1 is less than x. We also have x is less than or equal to 3. So we took these two inequalities and just turned them into one. We combined them together. That makes it a lot simpler than writing out two. And this happens in a few real world examples. But here, if we have a number line, you'll probably remember this from a few years ago. My number line. And I'm going to graph this compound inequality. Well, what this graph is going to tell me is all the solutions of this compound inequality. Well, I know that the lowest number x can be has to be greater than -1. So I'm going to have a circle here at -1. Now I can put it above or I can put it right on my line. Doesn't matter. But remember putting a point here. Now, when it's not equal to, our point is hollow or not shaded in. So it's not equal to, only greater than or less than. So x is greater than this, so we're going to continue on going this way until we get to 3, which is our other number. Now, x is less than or equal to 3, so I'm going to shade in that point. So I have this other point. If I shade it in, that means equal to is included. So what this graph is telling us is that any point that lies on this line that I just graphed, any number that falls in here, 0, 1, 2, 2.5, 3, will satisfy our inequality. So I can substitute any number in here and it'll work. So 1 is a part of this area. So is 1 greater than -1? Yes. Is 1 less than or equal to 3? Yes. So that's how we would graph an inequality or a compound inequality. All right, well, here's another example of a compound inequality. Now, this is a little bit more advanced where we have multiple things happening here. We actually have to solve for this. 10 is greater than 2x plus 4. All right, we were solving these yesterday. Then we have 2x plus 4 is greater than or equal to -8. Well, we can solve for these two separate ways. You can do that, but I want to show you a quicker way to do this. Now, in order to solve for this, we need to get x to be the only thing here in the middle of our inequality. So, I'm going to solve this by taking away my numbers from my x. So I'm going to take away 4 from the middle. All right, that eliminates my 4 there, my +4. I'm then going to take away 4 not only from this 10 on the other side of my inequality, but I'm also going to take away 4 from this side as well. So notice this is a little different. Take away from the middle and bring it to the outsides. So again, I'm going to place my line there to show I have a step. So I'm going to end up with 10 minus 4, which is 6, is greater than 2x, which is greater than or equal to -8 minus 4, which is -12. So I got rid of my 4 in the middle. So look, I only have 2 x's. So then my final step, just like you did with your other inequalities, is, since we have 2 times x, we're going to divide by 2, not only on the inside, but also on the outsides. I'm going to divide 6 by 2 and -12 by 2. Then 6 divided by 2 gives me 3. I'm going to keep my sign. It's greater than x, which is greater than or equal to negative 12 divided by 2, which is negative 6. I then have my compound inequality where x is all by itself. I then can have a number line where what do I have? Negative 7, negative 6. Where I see that x, or 3 is greater than x. So 3 is greater than x, not equal to, so I'm not going to shade. Then I'm going to bring this line all the way to negative 6, where I'm going to shade in my point because it is equal to as well, to negative 6. So that's how we solve for an inequality, well, that we have two different sides from. All right, so remember, we got to take away from the inside and then do the same to the outside. So it's like two separate steps. Got it. So let's think about water. Water has three different phases, three different states, as gas, a liquid, and a solid. All right. Well, we can make an inequality using water, saying that water is not a liquid when it is below 0 degrees Celsius and when it's above 100 degrees Celsius. Because when it's below 0 degrees, it's a solid, it's ice. If it's above 100 degrees Celsius, then it is a gas. It evaporates, it's steam. So the only time it's a liquid is in between the temperatures 0 and 100. All right, so let's write an inequality for that. So, okay, so water. I'm going to say that's W. Water. When is it a liquid? It's only a liquid when it is in between 0 and 100. So I got two numbers, and I have my water. Well, now we got to figure out. All right. Water is not a liquid above 0 or above 100 and below 0. So water is only water when it is below 100 and above 0. Okay. So there's our inequality, and then write this out. We got 0, got all these other numbers. We then have 100. So water is only water in between these two numbers, 0 and 100. Now we're not going to include those because right at 100 it starts boiling, turns into steam, and right at 0 degrees it's no longer a liquid, it's a solid, it's ice. Now there's one last type of inequality I want to talk about. One where the graph goes like this. If this was 10, say that was 10, and this is negative 10, and my lines went that way. They don't meet. They're two separate things. What happens here is this is an OR statement. With an OR statement, you don't have that compound inequality that's all together. You actually have the word OR separating them. So you're going to say that x is less than negative 10, or x is greater than or equal to 10. So you have two inequalities, but they're not combined like they were before. Compound inequalities can be graphed on a line using shaded points and unshaded points. Shaded using greater than or equal to or less than or equal to, and unshaded just using greater than or less than. In order to solve a compound inequality, we need to move everything from the inside of our inequality to the outside so that the variable is all by itself. And then OR statements, which are compound inequalities with an inequality or another inequality, have lines that do not intersect, so they go away from each other.